Nonlinear functions and their applications, part 1. So the learning objective here is that students are expected to be able to understand nonlinear functions and to apply nonlinear function in economics and business. So as the introduction, I will read this. Many times, quantitative business relations are described most accurately by nonlinear functions. So not linear function actually, yeah, nonlinear function. Three examples of nonlinear business relationships will provide an introduction to this function. First, in most cases, the average or per unit production cost of a particular product does not change at a constant rate as the quantity of production expands. Like in linear, we say that is a constant rate and it is described by the slope. Okay? Thus, as automobile production increases, the cost of producing a single automobile does not remain the same. The variation in average cost relates to production efficiency. For example, at low levels of production, the cost of producing an automobile is high because labor and machinery are underutilized. At very high levels of production, inefficiencies in management like quality control problems, errors on the production line, etc., may cause high average costs. Between these two extremes, labor and machinery are operating most efficiently and consequently, average costs are low. Secondly, a second nonlinear relationship in business is reflected in total revenue, and total revenue is product price times quantity sold, P times Q, received by a firm as the quantity sold increases. Okay? In order to simulate additional sales, most firms must gradually decrease the product price. These price adjustments cause total revenue to change at a variable rate as the quantity sold increases. Thus, total revenue as a function of quantity sold is described most accurately by a nonlinear function. Thirdly, measuring rates of growth is important to business and economic analysis. Population, additions to the capital stock of a nation or region, and sales of a new product are some of the variables which frequently are measured as a function of time like weeks, months, years. Rates of growth usually measured in most cases by exponential function. So basically, in nonlinear function, we start first with a function or drawing which is not linear or not like a line. Rather than we use like a quadratic function, cubical functions, exponential function, logarithm function. So these trees, examples are to describe on why we have to learn about nonlinear function, because life is not always linear. Okay, in this section we are going to learn about non-linear function. There are so many linear functions, but what we are going to go deep in is quadratic function. Okay, and second of all is logarithm function, and of course if there is a logarithm, then it also has an exponential function. Okay, this is only the three functions that we are going to learn in this semester. Even though there are so many functions like a cubic function or no polynomial function. Polynomial function means that you see that linear function we can say like y is equal to a plus bx. Yeah, so the x here has only power 1 or exponential 1. But quadratic function has the highest exponential for x is 2, so it is written like this. So here x has a quadratic exponential, yeah. Cubic, there are also cubic, yeah. Cubic has 3 exponential, or x power 3, it's the highest power. And other polynomial function which has a higher exponential in the independent variable. Okay, this is the general form of a quadratic equation. Y equal with ax squared plus bx plus c. Now quadratic function is symbolized by x squared here, or the independent variable should has the highest exponential as quadrat, and therefore it shouldn't be 0. So a should not be equal with 0. If it is equal to 0, then it becomes linear function. Okay, and the more general form of the quadratic function could be like this. So you see here, the quadratic is on x squared and also y squared. So this is also quadratic because every variable have the highest exponential as 2, quadrat. Therefore, the coefficient that glued to the quadratic independent variable, it shouldn't be 0. Okay, if it is 0, then it will become linear function again. So this is again the general form of quadratic function. You see here, if a and b is not 0, then the curve is a circle. Okay, circle. So this one, it shouldn't be 0, but both x and y have a quadratic exponential, so that is circle. We call that the circle curve. So the drawing of the curve will be circle. And then if a is not equal with b and has the same sign, the curve will be an elliptic curve. If a and b has different sign, then the curve is hyperbolic. If a is 0 or b is 0, so one of them is 0, the other one is not, then the curve is parabolic. So what are we going to learn here now is the parabolic form only. So this is the equation of parabola. Y is 8x squared plus bx plus c. So y-axis become the dependent variable and independent variable is the axis, the x, yeah. And parabola form is open up and open down like this. And this can be defined through the value of a. If a is smaller than 0, it will open down. Okay. If it is bigger than 0, it will be open up. So consider this as negative. Yeah, this is negative, not consider this as negative. This is negative, but you have to consider it as your saving account. If your saving account is negative, then your mouth will be formed like this. Okay, and if it is positive, your saving account positive, then you're smiling. Open down, open up. Okay, and now this is the form of another parabol where the x become the dependent variable and independent variable will be y. So this is the curve form will be seen again through the a. If a is bigger than 0, it will open to the right, and if it is smaller than 0, it will be open left like this. Okay. All right. Now, I'll show you the drawing on the Cartesian diagram. So this is the form of the parabol with y is as the dependent variable and x is the independent variable. So this is the form of ax squared plus bx plus c. Yeah, y is the dependent variable. You see this is the curve is open up and open down. So this is the form. And you see from the previous slide, I said that how to know that this open up and down. You see that through the a here, yeah. But the not you see that this is positive and it's open up, negative open down, or concave downward. And the difference between 1 to 3 with the same open up curve, that the first one here is cutting the x-axis, yeah, and this one is touching x-axis, and this one is floating from the x-axis, floating. How to know that this one could be cutting the x-axis and this is touching and this is floating is through the d here. What is d stated for? D is discriminant. Discriminant is b quadrat minus 4ac divided, no, b quadrat minus 4ac. Yeah, what is b and a? B and c. Yeah, b and c is here. So b is always the one who become the coefficient of the x with exponential 1, and c is without the x. Okay, so if the result of the b quadrat minus 4ac is bigger than 0, it will touching the x-axis. If it is equal with 0, the result here, it will, no, this is not touching, and this is intersects the cutting, sorry, intersect all the x-axis, and this is touching, and if it is smaller, then it will be floating. The same with this. Every positive d will be cutting the x-axis in 2 points. Yeah, remember, in 2 points. And touching means that this is only has 1 point on x-axis, and this is never touching x-axis, right? Another thing about the parabolic curve is that the curve has an extreme points. Extreme points mean the maximum point or the minimum point of the curve. This is the curve again, so I will draw a curve which is open upward. Yeah, what is open upward again? If a equal is a is positive and it's not touching the x-axis here, so then will be the d is smaller than 0. Okay, now this kind of curve has a minimum point here. So why we need to understand about a and d? First of all, we can imagine how the curve will be like, will be drawn, yeah, how it is like, and then we know also it can reach a minimum point or maximum point. Okay, this is important to the application later on that we are going to do. Okay, now to define the coordinates of the extreme points is this. So this is basically x, y, and I'll name it xm. It can be maximum, it can be minimum, depend on the value of the a over here, and it always has an extreme points. Yeah. Oh yeah, the parabol is also symmetries. Okay. So xm here is equal with minus b divided into a. Y minimum or maximum is b quadrat minus 4ac over 4a. So to conclude, the character of parabola will be given in the next slide. The form of the quadratic function will be like this, and then the standard form of a quadratic function when you are going to draw your quadratic parabola is to have this kind these three steps. First of all, you need to find out if it is open up or open down, okay, through a and through positive or negative value of a, and then find the maximum and minimum point as your second step. And third is to find the intercept point for x-axis and y-axis. And through the steps of the second step, or you can go through this first step, also you have to add the discriminant, whether that is a positive or negative value or 0, to find out whether the curve will be touching x-axis or crossing x-axis or floating over x-axis. Okay, so I'll add here d. Go through the d value. Okay, it can be bigger, it can be equal with 0, it can be smaller than 0. So before you draw like this one, here on the right side, you can you already have an image on how you are going to draw through this. If it is bigger than 0, okay, my parabola will be open up. And if the discriminant is equal to 0, okay, then open up but touching only one point at x-axis. And because of the a has a positive value, then my extreme point will be a minimum point. Okay, and then intercepting point for x-axis and y-axis, you know that if the d is smaller than 0, it's only touching for one point on the x-axis. And now you can define the y-axis. Why? To make the drawing well. Yeah. Okay, we'll go to the next example. Find the extreme points of the parabola. Y is equal with minus x quadrat plus 6x minus 2, and their intersection with the coordinate axis. Draw the curve. Okay. Y equal minus x quadrat plus 6x minus 2. Define the a given. What is a? A is minus 1. B plus 6. C minus 2. Okay. The steps on drawing. Steps to draw curve. First of all, define the a. A is already smaller than 0 since a is smaller, equal with minus 1. And then the discriminant here is b quadrat minus 4ac. Fill in 6 quadrat minus 4 times minus 1 times minus 2. Without knowing the value, without this having the result, I know that this is negative. Yeah, 60. Okay, now define that. 36 minus 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 is minus, so minus 8 here. And your d will be 36. Oh, this is positive. Yeah, my mistake. Okay, 36 minus 8 is 28. Yeah. Okay, so this is bigger than 0. It means that it will crossing x-axis and that will be crossing at 2 points on x-axis. The curve will have 2 points, 2 coordinates crossing x-axis. Okay, now you know that a is smaller than 0, so more or less our drawing will be like this. A is smaller than 0 means that the curve is negative, yeah, saving account negative. Your smile form will be like this, so it will be open down or concave downward, concave downward, and crossing 2 coordinates more or less like this, or it could be like this. Yeah. Okay. So what are we going to do next is to find the extreme points. Second extreme points, and it has, because it concave downward, so the point will be maximum point. Okay, xm, x max, y max. X max is minus b over 2a, so minus 6, 2 times minus 1. Okay, minus 6 over minus 2, 3. And y max is b quadrat minus 4ac over minus 4a. And this is actually d, yeah? So we have already d over there. And we have it here, 28. Minus 4 times minus 1, it's 28 over my plus 4, it's 7. So x max, y max is 3.7. Okay. So the third step is to find the intersection on x-axis and intersection on y-axis. Okay, this is the same with the linear function. Intersection on x-axis, you have to put y equal to 0. Okay, now let's start with our equation, quadratic equation. Y is equal with minus x squared plus 6x minus 2, and put y is 0. So your equation will be, go to the left, yeah, x squared minus 6x plus 2 now. Okay, change it to the left here, so then you'll come up with this. I want to make the x squared here is positive, so we can factorize it, or you can use an ABC formula. I'll try to factorize it first. Okay, see the left side, x squared. What is the factor of x squared? X squared factor is just x times x. So put x on the left side of the brackets, and then look at the right side. 2 has the factor of 2 times 1. Okay, nothing else, because it's a prime value. So 2 and 1. Okay, now this is plus. Positive is the result of positive times positive, or negative times negative, correct? So this should be positive or negative. Now look at this. Yeah, multiplicate the nearest value inside the brackets. 2 times x is 2x, and then the farthest, x times 1 is x. So add it, all of them, positive x plus positive x, positive 2x plus positive x is 3x, right? It should be 6x. It doesn't match. Okay, it means that our guess is wrong here. The guess of the value here, the value, the operation, the sign of the operation. Now change it to negative, negative, negative 2 and negative 1. Again, this is minus 2x and this is minus x. You don't come up again with 6x. So we cannot factorize it. We can factorize this equation. If we cannot do that, use ABC formula. Formulation. Okay. So the axis, you know the ABC formula. I don't teach you anymore since you know that already. Minus b plus min d, b quadrat minus 4ac, it's d, right? You divide it with 2a. So minus b, what is b again? Minus b is minus 6. Plus min, the d that we got before is 28 over 2 times 1. So minus 6 minus is 6 plus minus square root of 28 is 5 something. 4, yeah. Okay, I'll write like this, 4 times 7, right? Over 2. 6 plus minus 2 square root of 7 over 2. Now 6 over 2 plus min 2 square root of 7, 2. Can divide it 3, 1. So 3 plus minus square root of 7. What is square root of 7 again? Oh, wait a minute. 2.65. 3 plus minus 2.65. 394. Yeah. So our first x is 3 plus 2.65. It's 5.65. And the other two is 3 minus 2.65 is 0.35. Okay, so our coordinates will be intersection on x-axis is 5, 6, 5, 0 and 0.35 with 0. Yeah. Okay, next is intersection on y-axis. Now this is much more easier. X should be 0. Just fill in the x as 0. Okay, 0 plus 6 times 0 minus 2. This will be minus 2. And the intersection on y-axis will be 0 because x is 0 and the result is y is minus 2. Okay, now let's draw it. Okay, again I will conclude the result that we have so far, that we got so far from y minus x quadrat plus 6x minus 2. We know that the curve will be open down and it will intersect the x-axis like this, and the extreme point is at 3.7. and it intersects with y axis, x-axis is at 5.650 and 0.350 intersect with y-axis. Yeah, y-axis. Yeah, this is x-axis. Y is 0. Y-axis. X is 0. 0 minus 2. Okay, now let's draw it. I'll make it bigger. Okay. We have 3. I like to put it like this because I can see the range. 3, 7, 0 and minus 2, 0.350, 5.650, 0 to 5, minus 2 to 7. Half then for the x-axis. 1, 2, 3, 4, 5, 6, 7. 1, 2, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Okay, 7, 2 minus 2y minus 2 here minus, so this is 1, 2, 3, 4, 5, 6, 7, 3.65, 1, 2, 3, 4, 5, too small, 1, 2, 3, not enough. Okay, I will extend my picture then. I'll make the scale on x-axis half. So 1, 2, half, yeah, half, 1 half, 2 half, 3, 4, 5. Now I have enough here. Good. 6 here, etc. Okay. Now, first of all, 3.7 is the extreme. So this is my highest point. 3, 7, 3 here. 3, 2, 7. This is my 7, so this is 3.7. Okay. Make it with 3.7. Now, 0 minus 2 is the next here. What is this? Oh, intersect with y-axis. So it will touching here, the x-axis. Touching the y-axis here. Yeah, 0 minus 2 is this one. 0 minus 2, this. Okay, now x-axis intersection 0.35 and 5.65. 0.35 is here, 565 is more or less here. Okay, 35, this is 12, 3 is more or less here. And then 565, this is 5.5, 5.65 is, yeah, kind of here. Okay, if you do it with ruler, yeah, so it will be symmetric. Mine, I think, is not too symmetric. So this, and you know, the curve is downward over there, so you can draw like an artist here. Ups, 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 ups. Okay. It's not too it's not touching this. Aha. Then this is straight line. This is, oops, and it should touch this. Yeah, straight line. So this should be straight here. Oops. Okay, so this is the curve. Done. Yeah. Okay, now do this exercise and quickly deliver it. I'll expect it. Again, I will put down on your LMS when you should deliver it along with other exercises. Yeah? Okay.